All right, so moving on to the next section in Chapter 11. Now that we know how to simplify rational expressions, now we're going to start looking to do operations with them: multiply, divide, add, and subtract. So we're going to start off today with multiplying and dividing our rational expressions. So when we multiply and divide rational expressions, okay, obviously that means we're going to be working with two different expressions, and we're either going to be multiplying or dividing them together. So let's say we had an example of something like r squared x over 9t to the third times 3t to the fourth over r. Okay, so now obviously this is an example of multiplying our rational expressions. This is one rational expression here. This is another rational expression here. And we are obviously multiplying them together. So in order to do this, what we want to do to make this easier for ourselves, because we know that when we multiply fractions, if you remember, when we multiply fractions, it's simply just if I did 1/2 times 2/3, I would multiply straight across the top. I would multiply straight across the bottom. This would give me 2/6, and then I'd have to simplify it from there. It's essentially the same concept, okay? So really, when we have a multiplication symbol here, what we can actually do is we can kind of forget that it's even there and really just make this one big fraction, where this right here, this is my numerator, and this is my denominator. So now that we have done that, the next step is to simplify. And just like we would simplify with a regular fraction, if we see a factor that's both on top and on bottom, we can simplify that out. So I'm going to start with looking at this r squared here. So I see an r squared on top. If anywhere in the bottom I see an r or an r squared or something that has r as its base, I can look to simplify. Well, here I have an r squared. Here I have an r. And we should remember that r squared over r, what do? I subtract the exponents, so I'm going to get an r in the numerator. 2 minus 1 gives me that 1, so this is an r in the numerator. I'm going to do the same with x. So I see an x on top, but I don't see any x on bottom. So that's fine. That means that the x is just going to stay in the numerator. I'm going to do the same thing with my coefficients. I see a 3 on top. I see a 9 on bottom. 3 over 9 is going to simplify to 1 over 3. Now, whenever we work with numbers, I always put numbers in front. I always work with them as coefficients in front. So the 1 is going in the numerator. The 3 is going in the denominator. Okay, so I just continue on with what I'm working with here. I'm going to look at now the t's. I have a t to the fourth. I have a t to the third. T to the fourth over t to the third. I subtract the exponents. 4 minus 3 is going to give me t, and that's going to be in the numerator. So my final answer here, now that I've gotten everything simplified and canceled out that I can do here, I don't need to put the 1 coefficient there. So really, my final answer is going to be r x t over 3. That would be the final answer here. Okay, now this one here specifically, we're able to do this because each of these, the r squared, the x, the 3, the t to the fourth, each of these are their own factors. It's a little bit different when we're working with binomials and trinomials. So, for example, when we're working with a problem like a plus 4 over a squared times a over a squared plus 2a minus 8. So when we're working with a problem like this, it's going to be a little bit different. Here, as we said before, each of these were its own factor because we were multiplying these all together. There was no addition or subtraction in this. Well, now we have binomials and trinomials. We have addition and subtraction. So we can't just work with a as its own factor in a plus 4 because that's not correct. A plus 4 is its own factor. It's essentially like saying this. You have parentheses around the a plus 4. That's its own factor. It can't be split up. So when we see binomials and trinomials in this, we have to remember factoring. So when we see binomials and trinomials, the first thing that we want to do is look to factor. So for this first one here, I look to factor the a plus 4. Now, a plus 4 can't be factored, so we leave it as a plus 4. I look to the bottom here, a squared. That doesn't have a plus or a minus. It's not a binomial or a trinomial, so I can leave it as a squared times. Same with the numerator up here. A is not a binomial or a trinomial, so I can leave it as a. But now I have the a squared plus 2a minus 8. This is a trinomial. Trinomials have to be factored. So I use my trinomial factoring method, two numbers that multiply to get negative 8 and add to get 2. Whoops. So two numbers that multiply to get negative 8 would be negative 2 and 4. And when I add those together, I do get 2. So this is going to factor out to be x, a. We're not working with x's. A minus 2 and a plus 4. Now that we have this completely factored out, I can't factor this numerator, I can't factor this denominator, I can't factor the numerator, and I can't factor this denominator anymore. Now I can do what we did in the top problem. I can just kind of extend this factor or this fraction bar and now say, okay, do I see any factors that are the same on the top as on the bottom? And here I see this a plus 4 and this a plus 4 are the same on top and bottom. So I get to cancel those out. With the a and the a squared, I would do the same thing as I did up here, since they're just factors on their own. They're monomials. So a over a squared, this a would get canceled out, and this a squared would just become an a. So on top, what am I left with? Well, I don't have anything left, but remember, when we're working with fractions, if there's nothing left after simplification, that just means it is a 1. So on top, I have a 1. On bottom, I have an a, and I have an a minus 2. And I can just leave my answer like that. So the simplified version of a plus 4 over 2a a squared times a over a squared plus 2a minus 8 would be 1 over a times a minus 2. That would be our final answer. Okay, so I've given you 3 different problems up here. I want you to try these on your own. Pause the video and see if you can do them. Now remember, when we're working with just monomials, you can just extend the bar and work normally with the simplifying what you have on top and what you have on bottom. When you have binomials or trinomials, like we see in these, we need to look to factor first. You factor first, then you extend the bar and say, okay, do I have a factor that's the same on top as I do on bottom? So again, take about 5-10 minutes, pause the video, see if you get them correctly. Okay, so hopefully these were the answers that we got. For the first one here, we see that the 3 and the 3, they can be canceled out or simplified. The 8 and the 16, they would simplify. They both have a common factor of 8, so the 8 would become 1, the 16 would become 2. The x squared and the x squared, those can also be canceled out. So what we're left with on top, we have an x and a 1, and 1x is just x. And in the denominator, all that we're left with is 2. So my final answer is x over 2. In the second one here, we notice this is a binomial, but it can't be factored at all, so we leave it as x plus 3. The bottom is just x. The top is 5 because those are monomials. But the bottom trinomial here, this can be factored to be x plus 4 and x plus 3. 4 times 3 is 12. 4 plus 3 is 7. Now, once I factor it, I realize, okay, I have an x plus 3 and an x plus 3. These two can cancel each other out. So now I can't cancel anything else out on top and bottom. So on top, I'm left with just a 5. And on bottom, I'm left with an x times an x plus 4. So that would be my final answer here. Now, over on this third one, we see that we can factor out a couple things here. First of all, the top half of this fraction here would factor out to be y minus 4, y plus 1, because negative 4 times 1 is negative 4, and negative 4 plus 1 is negative 3. So that would be the top half here. The y plus 5 would just stay the same, both on top and bottom there. The y squared minus 4y, this can have a GCF of y. So we would factor out a y, and we'd be left with y minus 4. Now that I've factored everything out, I see a y minus 4 and a y minus 4. So those two get canceled. I see a y plus 5 and a y plus 5. So those two get canceled. Now here's where a lot of people will make a mistake here. They see that what's left here, they have a y plus 1 and a y. And what a lot of people will do is they'll take this y and they'll take this y and they'll cancel them. And that you cannot do. Okay, that is an incorrect thing, and you have to make sure that you don't do that. The reason being is because y in this top half here is not a factor. The factor here is y plus 1. Okay, y is not the factor. That would be like saying 3 is a factor of 4. But it's not, right? 3 plus 1 would be 4, but 3 is not a factor. So y cannot be canceled with this y because this y here is not a full factor. It's part of a factor. It's not the full factor. So you cannot cancel a factor with an individual term. This is an individual term y. If this was just y up here, if it wasn't y plus 1, then of course you could, like we did over here. The x squared and the x squared. These were individual terms. Okay? So make sure that you do not cancel those y's. That is completely wrong. So we have a y plus 1 up top. We have a y on bottom. This would be my final answer. Just y plus 1 over y. Okay, so we did multiplication. Let's take a look at division. Now, the good thing about multiplication and division, at least with our rational expressions, is there's really no difference between the two. There is one step previous, and then everything else is exactly the same. So let's say I had one that was 2x plus 6 over x squared divided by x plus 3. Okay, let's say we had this. So first of all, you may be saying to yourself, well, this is a rational expression because it's a fraction, but this isn't a rational expression. Well, remember, any number, anything without a fraction, we can always make a fraction by just putting it over 1. So that should be the first thing. If you ever see something that's not a fraction, you can make it a fraction by putting it over 1. So that's the first thing. But now the kind of important part here, the second part of this. We talked about multiplication. Now we're talking about division. Well, when we have division, and some of you may remember this from 8th grade, whenever you're dividing two fractions, you keep, change, flip. KCF or KFC, some teachers may have called it. You keep the first fraction exactly the same. 2x plus 6 over x squared. You do nothing to the first fraction whatsoever. The sign, you change the sign. This is division. You change it to multiplication. The second fraction, you will flip it. It's x plus 3 over 1. When we flip it, it's going to become 1 over x plus 3. Now, we have a problem like the ones we were doing before. It's a multiplication problem. I see a binomial here. I need to factor the 2x plus 6. The 2x plus 6 can be factored by GCFing a 2 out. So you're left with x plus 3 over x squared times 1 over x plus 3. And now I get to cancel things. I see an x plus 3 and an x plus 3. They cancel out. I have nothing else that cancels on both top and bottom. So I'm left with just a 2 on top, or 2 times 1, which is 2. And on bottom, I'm left with just an x squared. So my answer would be 2 over x squared. So even with division, there's really no difference between multiplication and division. You just have to remember, keep, change, flip, KCF. Or KFC. KFC is a little easier to remember. It's just obviously you change the division sign and flip the last fraction. But most people do remember it by KFC. All right, so let's do one more. Instead of just working with, some binomials, let's throw in some trinomials, some polynomials here. So let's say we had y minus 3 over y squared minus 10y plus 16 divided by y squared minus 9 over y minus 8. Okay. So, first things first, I see that it's division. What we have to do with division is keep, change, flip. Keep the first one exactly the same. Y minus 3 over y squared minus 10y plus 16. Change division to multiplication and flip the second fraction. Y minus 8 over y squared minus 9. Okay. Now, I work with this as if it were a regular multiplication problem. I see binomials and trinomials, so I need to factor. Y minus 3 does not factor. We leave it as y minus 3. My trinomial on the bottom here, y squared minus 10y plus 16, we'll factor that in our normal trinomial method. What two numbers will multiply to get 16 and add to get negative 10? That's going to be negative 8 and negative 2. So this is going to be factored to be y minus 8, y minus 2, times the y minus 8 is just going to stay as y minus 8. You can't factor that. And then the y squared minus 9, this can be factored. This can be factored by the difference of squares. Remember, if I can take the square root of both of these and get a perfect square, which I do, then that can be factored as y minus 3, y plus 3. So now that I've factored it, now it just becomes a cancellation game. What do I have on top that I have on bottom? I see a y plus 3 and a y plus 3. I see a y minus 8 and a y minus 8. Okay, so what's left on top? Well, nothing, but remember, if everything gets canceled out on top, I always put a 1 in the numerator. In the denominator, I have a y minus 2, and I have a y plus 3. And that would be my final answer. 1 over y minus 2 times y plus 3.